Hey everybody. All right. I think the topic of today's lesson is pretty self-explanatory by reading the title slide. We're going to take a look at the area formulas for 5 of the figures in this picture, and we're going to figure out where they came from. Right. Now the point here is that mathematicians do not just make up formulas out of like thin air. There's a reason for the formulas, and that's what we're going to talk about. Right, we're going to start with this, a rectangle. We've already gone over this, but I just wanted to review this real quickly because all of the other formulas that we're going to work on today are based on this premise about the area of rectangles. All right, so the area of a rectangle is length times width. I want you to see that here, when I wrote the area formula, I took out the multiplication sign. This is really not best practice to write the x as multiplication because then it gets a little bit confusing. Like, is that a variable or what? So I think it's better to write it this way. I just want to remind you that area is figuring out how many squares fit on top of something. Another way I say it is how many square units could you draw on a surface? Right, so a very important thing is remembering what a square unit is. So in this particular example, you can see I'm outlining one of the squares. Each square here is considered to be 1 square centimeter. That means it's 1 centimeter by 1 centimeter by 1 centimeter by 1 centimeter. So we want to figure out how many of those square centimeters are here, but we don't really want to count that. All right, well, this is when what elementary school students learn about arrays comes in very handy. Right, so what we're going to do is length times width, and what we've got here is 18 groups of 12. Right, so we have 12 centimeters up and down, and we have that 18 times. Right, well, that's when you use multiplication. 18 groups of 12. That's going to tell you how many squares there are altogether. So you can see that this is 216. So the unit here is centimeters squared, so note that little exponent 2. All that means in this case is we're not talking about just a centimeter in length like this. We're talking about a centimeter squared, which is 1 centimeter by 1 centimeter by 1 centimeter by 1 centimeter. Okay, so that's where the area formula for a rectangle comes from. Just a quick aside, sometimes students ask me, how do you know which one's the length and which one's the width? Well, most of the time, length is the longest side. Right, that's it. So this is length because it's longer than the width. That's all. All right, parallelograms are very closely related to rectangles. I found this on the math guide site. In fact, I found a lot of information on that site, so much so that I cited this website at the end of the video. All right, I'll show you how I did that. All right, so if you have a parallelogram, that means your opposite sides are parallel. So you could say 2 pairs of parallel sides. So that's kind of cool because what you can do is you can cut a line that goes from the top to the bottom and meets at a right angle. That's, by the way, what we would call the height. Very important that you get that meets at a right angle. And then you can see they've shaded it in here. Well, that can be moved over here. This will match right up, and it will actually make a right angle here. Now you can see you've got a rectangle. Oh, base times height, right? So the area of a parallelogram is base times height, right? Sometimes I see the base written up here, which is a little bit more clear sometimes because this side didn't get cut. All right, so let's go ahead and use that then. So since area is the base times the height, in fact, you can see it's written at the top here, that's going to be 15 times 8, which is 120. So the area of this parallelogram here is 120 inches squared. So this time, note it's inches. All right, so that means I could draw 120 1 inch by 1 inch by 1 inch by 1 inch squares on that surface. Okay, triangles. All right, I thought Math Antics did a great job with triangles, so I used a couple of pictures from their website. So here's a rectangle, 3 meters by 4 meters, so you know that's 12 meters squared. Well, a triangle is just half of a rectangle. So if you cut this rectangle in half, then this area is going to be half of what this is. This was 12, so half of that is 6. So So that's where we get the area formula. It's half the base times the height, right? Base here, height here. For some reason, with triangles, we call it base and height, and with rectangles, we call it length and width. I'm not even sure why we do it that way, but we do. All right, so then what we've got here is 1/2 of 4 times 3, and half of 4 times 3, so that would be half of 12, is going to be 6. You could also say half of 4 is 2, 2 times 3 is 6. So any way you want to do that, that works. All right, and again, note the unit is meters squared. Oh, that's my phone, just ignore it. All right. All right, now, I can understand where you might be, but that was an easy one because you just cut the rectangle in half. What if you have one that's not quite so easy? All right, well, here's one. Okay, so the purple part is my triangle. The red line here is the height, okay, sometimes referred to as the altitude. This meets the base at a right angle, just like parallelograms, right? And then I want you to see what happens here. Once you have this line in here, you can split the triangle up into basically 2 parts, and then you can draw a rectangle for each part. Okay, just make sure that this line at the top is parallel to the base and goes right through the vertex here, right? And then here's your rectangle. Well, I think you can see by looking that this triangle is half of this rectangle, and this triangle is half of this rectangle. So then, since this is half of that, and this is half of that, then this makes the whole thing half of that large rectangle. So same formula. It's still half of the base times the height. Okay, so in this case, you can see I did the math. So the area of this is 6,670 millimeters squared. All right, trapezoids are fun, and I actually did this one myself. So I created a trapezoid out of paper. And let me tell you what I did, and then I'll explain more on the next slide. So trapezoids have one set of parallel sides. Okay, they're always quadrilaterals. And in this side, I have the top and the bottom as the parallel sides. So the sides that are parallel are referred to as the bases. So my bases are along the top and the bottom of this trapezoid. All right, then I cut the trapezoid in half, and then it's important to cut it halfway between the parallel bases. So all I did was fold it over so that the top matched the bottom, and then I cut along that line. Now I'm just going to turn the top piece. I'm turning it clockwise, right? You can see I keep turning it, and then down here I've got it to where it's going to line up. All right, so since this side and this side really both came from this part here, since they were the same slant, they're going to match up. And sure enough, they do. They match up right here. Right? And just keep in mind that this side here was the same side. That makes these the same type of slant. So these two sides are parallel, right? So we've got this side parallel to this side because I cut it that way. And then we've got this side parallel to this side. So yeah, when you do this, this makes a type of parallelogram. Try some yourself if you're interested. All right, so this was the first picture, okay, and I labeled my trapezoid with the bases. With trapezoids, we use subscripts to tell them apart. So I'm calling this one base 1 and this one base 2. Sometimes it's the other way around. This is base 2, this is base 1. It doesn't matter. The height matches both of the parallel lines at a 90-degree angle. Right? So that's an important thing to know about trapezoids, and we're going to use this in the formula. Right? So this area is going to be the same as this area because it's all the same trapezoid, right? But once I've cut it, this is only half of the height, right? Because here's my h. This is half of it. And down here, my base is now this base plus this base because I flipped it over. So I made one of them black and one of them blue so you can see that. All right, so we're going to go back to our formula for area. The area of a parallelogram is base times height, and we're going to use that to figure out the area of this trapezoid that we have now cut so it makes a parallelogram. All right, so the base is B1 plus B2. Right, I just changed the order around of those, but it's the same, times half the height. This is the base times the height. All right, then down here what I did is I just rewrote it. I put this first. It doesn't matter because multiplication can be any order. It's called commutative. And then I got rid of the little x for the algebra reasons. All right, it's not the best practice to have that in there. And as long as the variable's right next to the parentheses, it means multiply. So this is half of the height times the sum of the bases, or b1 plus b2. This is the formula most often used for the area of a trapezoid. Okay, and here's a situation where I've used the area formula to find the area of this. I'm just ignoring the 7 and the 5 because I don't need that. I just need the bases and the height. So half of 4 times 6 plus 8. Half of 4 is 2. 6 plus 8 is 14. 2 times 14 is 28. Note I just said units squared here. If the units are not given, then we just write it like this, units squared. Okay, the last example is circles, and we've already gone over the area formula for a circle. It's pi times the radius squared, but I want to talk to you about where that came from. So just like I did with trapezoids, I drew a circle, right? And then I manipulated the pieces a little bit to make something else. So here's what I did. I drew lines in here, and I used a protractor to measure these out. Each of these is 45 degrees. So basically, I'm cutting like the perfect pizza here. Into 8 pieces. Then I cut them up, moved them apart on the counter, and then I just took these pieces and I rearranged them into this design here. All right, so I've got like 4 one way and 4 the other. Keep in mind the area of this is going to be the same as this. All I did was take this and cut it differently. It's still taking up the same amount of two-dimensional space. All right, well, let's see how we then get from this picture down to this formula. All right, so if you look, this does make a type of sort of crude parallelogram. It's that just that the edges are curved. All right, well, we're going to basically take that into account, this curvy edge thing, when we do the formula. All right, so I want you to note that I drew this line in here as a picture of what the height would be. And you can see it's a radius. It's a radius of the circle. All right, we're going to use this. Area is equal to base times height to see how mathematicians figured out the formula for the area of a circle. Okay, so we need to remember that the height is the radius of the circle, and the base right here is half of the circumference. Oh yeah, it's 4 pieces and 4 pieces on the top, so that would be just half of the circumference. All right, so since that's the base and the radius is the height, in the formula, we wrote it as half the circumference times the radius. Then we're just going to substitute some things here. So remember, the circumference is the same as pi times the diameter. We learned that yesterday. So half of pi times the diameter times the radius. Then, just to make things easier, so we don't have too many things in the formula, what the mathematicians did is replace the diameter with 2 times the radius, because remember, the diameter of a circle is 2 times the radius. There's the radius, the diameter is 2 of those. All right, and then take a look at this. All of this is actually getting multiplied together. You wouldn't really even need these parentheses here. I'm just putting the parentheses in to keep it a little more organized. So what we can do is 2 times 1/2, that's just 1. So we don't need that anymore. So that leaves us with pi times r. And then remember, r times r is r squared. So that's how we got the formula. Area of a circle is pi times radius squared. All right, so then here I'm using that to find the area of this circle. So pi times radius squared, so pi times 9 squared. Right here I'm writing it as 81 pi inches squared. We often write the number first. By the way, mathematicians would refer to this as the exact answer, right? This isn't very practical though. Let's say that this was like, I don't know, a circle that you're maybe having on the top of a cake, so you're trying to figure out how much frosting you need here, right? This isn't useful, right? So what we do is we use 3.14 instead of pi. So 81 times 3.14, I have no idea why I wrote that twice, but here's the correct answer here. The area of this maybe top of a cake or something would be 254.34 inches squared. All right. Right here, I want to tell you about my works cited page. I just put the web address here. If you're interested, you could check this website out yourself. And I took this little picture from the website so you can see, oh, yeah, they did this too, but they cut it up into a lot more pieces. And basically what they did is they've changed this to pi r right away, so you can see it's pi r squared. All right.